Alright guys, this lesson is titled Reasoning in Algebra and Geometry. For this lesson, we're basically covering math concepts you guys already know, but we're going to basically back up each step in solving a problem with a property of some sort. So here are the main problems or the main properties we're going to cover today. We have an addition property, subtraction, multiplication, and division. Those are really just telling me whatever I do to one side of the equation, as long as I do it to the other side, um, then that is okay. So if I have an equation A equals B, then if I add C to one side of my equation, then I add C to the other side of the equation, I'm using the addition property. Right? Same idea with subtraction property, multiplication, and division here. Right? The reflexive property, basically kind of restating if I have some quantity or some variable, it is equal to itself. Doesn't seem like that would be all that useful, but you guys will see how that's useful in the future. Symmetric property, if I have an equation of A equals B, I can swap the order of those and say that B equals A. And then the transitive property, kind of an extension of the symmetric property. If I have three values, A, B, and C, say I know that A is equal to B, and I know B is equal to C, I can then make the conclusion that A is equal to C. Right? And then the substitution property, if A equals B, then I can replace A with B in any expression. Right? So for instance, if I had A equals 13, I could replace B with 13 as well. Right? Kind of, you're just substituting in. Right? All right, guys, distributive property you have also seen before. So when we are using the distributive property, we're just multiplying to distribute a or a number to each term of the sum or difference within parentheses. You'll often see it like this, right? Just a number or a letter outside. That means that it can rewrite that as a times b plus a times c. Same idea when we're subtracting. Just be careful with your sign here. Make sure that you are subtracting and not suddenly changing that to addition. All right. Let's see. Let's move on to problem 1. So I'll just explain this as we go through, and I'll give you guys some time to try problem 1 down below. So basically, you want to be able to, with every step of solving an equation, you want to be able to back it up with a reason. So if I break up this proof, on the left side I have all my steps, and then on my right side I have all my reasons. All right, so say I'm given the problem that you guys can see on the right. I'm trying to find the value of x. It goes with this diagram here. You can show every step. So we'll start with the statement here, angle AOM and angle MOC are supplementary. And the reason for that is that we know that a linear pair is always supplementary. So based on the diagram, I see that this is a straight line. So those two angles are going to be supplementary. So then the next step is showing, okay, the measure of angle AOM plus the measure of angle MOC is 180. The reason why I know that is because based on the definition of supplementary angles add to 180. Next step, 2x plus 30 plus x equals 180. I'm basically just substituting in values for each of those. So I'm using the substitution property. And then from here, I guess you could argue, I don't really love that they say distributive property here, guys. I would actually say here that we're just combining like terms. Really, when I think of distributive property, I would be multiplying x by 2x and then x times 30, which I'm not. So I'm actually going to change this little typo here, combining like terms. And then from there, I subtracted 30 on both sides. So 180 minus 30, right, gives me this here. So I use the subtraction property of equality, and then I divide it on both sides to get x equals 50. So then I use the division property of equality. All right. So you guys pause the video, try number 1. Creating a 2-column proof, just having your steps on this side, and then your reasons on this side, and then I'll show you guys the work. All right, guys, this is more or less what you should have. You don't have to have the same exact wording, but first thing you want to start with is what's given typically, right? So I'm just restating that. That means that ray AB bisects angle RAM, so that's given. The next step, because I know I have a bisector, remember guys that bisectors split angles in half, or you could have a bisector split a segment in half, but in this case we're talking about an angle. So because it splits it in half, I know that the two smaller angles are going to be congruent. They're going to have equal measures. The next step, because I know they're congruent, I can set our angle RAB, which has x in there. I'm substituting that in, and I'm substituting 2x minus 75 in for angle BAN. So I'm using the substitution property. And then you guys could do this in a few different ways. So the way I did it, I subtracted 2x on both sides. So I use the subtraction property of equality here. And then I have negative 1x equals negative 75. So to get rid of the negative 1, I divided by negative 1 on both sides. I use the division property of equality. All right. So take a look at that. I'm actually going to erase because I have stuff underneath here. All right, guys, the properties of a congruence pretty similar to the properties of equality. You're just using that congruency sign. So, right, instead of numbers, you're going to put in the actual segment. So you have segment AB is congruent to segment AC versus saying like the measure of segment AB is equal to the measure of angle of segment AB. So really similar to what I just went over, reflexive, symmetric, transitive. Well, let's take a look at problem 2, apply it here. So what is the name of a property of equality or congruence that justifies from going from the first statement to the second statement? Really, to know whether you're dealing with equality or congruence, just look at the sign, right? So if you have that, that's an equal sign versus congruence. It's like that. I'm not going to be too much of a stickler about the two, but just know that there is a difference. So looking at problem A, you guys can see to get from step 1 to step 2, right? You're just subtracting 9 on both sides, and you have an equal sign there. We're going to call that the subtraction property of equality. The next one here, little hint, I have that congruent sign, right? So that's why we're saying congruence here. And so here we have 3 statements. That's going to be a hint to me that we're going to be using transitive anyways, but think about, okay, angle O is congruent to angle W is congruent to angle L, so then I can then state that angle O and angle L are congruent, right? Typically, you're looking for 2 different angles or segments connected by the same one, right, for your first 2 statements, and then your third statement is making that connection that the first and the last O and L are congruent, right? And then the next one, we have the measure of angle E equals the measure of angle T, so the measure of angle T equals the measure of angle E. So when we're just swapping the order, right, think about if 2 things are or if you have a drawing that's symmetric along the line, right, if you fold the paper, it's going to be equal either way, so you're just swapping your order. That's a symmetric property of equality. Little hint there is we have that equal sign. All right, guys, so you pause the video here and try number 2. All right, guys, so check your work. For A, we have the symmetric property of congruence. For B, we have the distributive property. For C, we have the division property of equality, dividing by 1/4 on each side, and then for D, we have the reflexive property of equality. All right, and moving on. So just a little more practice looking at a two-column proof, guys. We have we have a given statement here, and we're trying to prove this statement. So that's how typically you'll be given a proof. You'll be given some pieces of given information and then a goal in mind. So let's just see how it was approached here. So looking at number 1, they stated that the measure of angle 1 equals the measure of angle 3. So that's true according to this diagram. So it wasn't as like a, actually it was a given statement as well, but also you guys can see in the diagram, you can see those arc markings. So that's given. And then they're stating the measure of angle 2 equals the measure of angle 2, kind of explaining the obvious, and that's the reflexive property of equality. And then they're stating if you add the measure of angle 2 on both sides of that original equation, right? We're just using the addition property of equality. If you add something to one side of your equation, you can add it to the other side, and in fact, you should be adding it to the other side. And then they're explaining, okay, AEC is going to be equal to angle DEB, and that's just the angle addition postulate. So, the measure of angle 1 plus the measure of angle 2 equals the measure of angle AEC. I'll highlight that for you guys, so you guys can see measure of angle 1 plus the measure of angle 2 is both angles combined. And then they're making the other statement that the measure of angle 3 plus the measure of angle 2, which I'll just underline in red still, the measure of angle 2 equals the measure of angle DEB. Let's use this color here. Keep reusing colors. That one. So DEB. A little bit confusing here, but hopefully the color coding you guys can follow at least. And then, based on that, we can then state that the measure of angle AEC is congruent to the measure of angle DEB. Okay, so we're just substituting in what we found before, right? Based on our conclusion, right? These are the same. We know these are the same. So then we can then know for sure those are the same. All right, guys, actually, I'm going to have you guys pause and try number 3. Yeah, I'll have you guys just try number 3 for now, and then I'll show it to you. All right, guys, here's your answer for number 3A. So here's your two-column proof, kind of following what we did up here, only we're dealing with a segment instead of an angle, or a set of angles, right? Dealing with different segments. Okay, so double check your work. So for part B, guys, in problem 3, why is statement 2 necessary in the proof? You're kind of just making it obvious what your train of thought is. So where you guys see like segment BC is congruent to segment BC using the reflexive property, it doesn't seem like it's that necessary. You guys can see the same step here, but I think it's good to show that you're adding the same quantity to both sides because these two segments are congruent. All right. All right, one last set of problems to try, guys. Pause your video, and then I'll show you the answers. All right, guys, and then here are your answers for 1 through 4.